Okay, thank you very much for coming to this presentations of IEEE Education Society Distinguished Lecturer Panel that is interactive. Thank you very much. I am going to introduce the speakers. Before that, here is all the Education Society events, the major events during the IEEE Education Week 2024. So this session is about Education Society Distinguished Lecturer Panel. To get all the Education Week events, you can go to the link I am providing here, educationweek.ieee.org. Okay, I am Amadou Salia Hassan. I am presenting this session. The first presenter will be Carlota Berry. She is going to talk about robotics for streets, open source robotics for academics and community. Carlota is a professor in the Department of Electrical and Computer Engineering at Rose Hillman Institute of Technology. The whole bio is on the vTools site. You can reach there, and Carlota is free also to present herself at the beginning of her presentation. The second presenter is Mr. Johan Marques Baha, professor at University of Antwerp in Belgium. So he is going to talk about the role of standardization in the design of remote laboratories in engineering education. Johan is also was member of the standard, IEEE standard 1876 on online laboratories, and he's also member of the IEEE Education Society Standard Committee. The next will be Maria Paloma Diaz. I used to call her Paloma. She's going to talk about virtual mixed and augmented reality, affordable and useful experiences in education. She is full professor at Department of Computer Science and Engineering of Universidad Carlos III de Madrid. Okay, thank you very much for participating to this panel. I'm sorry I have PM before your name. I don't know what it means. I think my mistake. And we have the next one, the last one is Perez Diego Zapata Rivera. He's going to talk about technology enhanced assessment system, opportunities and challenges. Yes, for sure, we have challenges now with all the AI in the loop. So we are waiting to hear from Diego. And then we'll have discussion and questions and answers. And for the public, if you need to get distinguished lecturers from IEEE Education Society, I'm providing you the link of the distinguished lecturers. Here are the new one, 2024-2025 distinguished lecturers. Thank you very much for attending this session. Last slide is about inviting everybody to attend or to contribute to see what is going on. with IEEE Education Society to be involved. We are providing here, for example, all the conferences, the flagship conferences, and also we have high impact publications. So you can attend tomorrow's, the next session will be also about the editors and editors in chiefs and the associate editors of IEEE publication. They will present interesting hints about how to get published in IEEE high impact publications. So thank you very much. And in this session coming also, we have young professionals that are also being active in our society. Thank you. So Carlota, you have the floor. You can share your screen.
You're muted. There you go.
Oh, sorry. It says I don't have permission to share my screen while the other
You might need
participant
to
is sharing.
stop sharing. Yeah.
Okay.
There.
Okay. Sorry. Okay, let me try now. And I do have some videos, so I was trying to share sound. I don't see that, but let's just see how it goes. Okay. So please confirm for me that you are able to see my slides.
Yes, we can see you.
Okay, hold on. It's not showing on the correct screen. So let me try again. You should be seeing the slides with my captions now. Let me try one more time and make sure it's on the right screen.
Should also be in full screen.
Yeah, I put it in full screen, but it's not showing the screen where the full screen is. So can you see it now? Yes, looks okay?
Yes.
Yes.
Okay, so I would like to thank you all for inviting me to speak today, and I am honored to be one of the new distinguished lecturers for the IEEE Education Society. And as my esteemed colleague said to me, I am an endowed professor in electrical and computer engineering at Rose-Hulman Institute of Technology. And I am also a member of the multidisciplinary minor in robotics. So because of that, although my title says electrical and computer engineering, I actually teach courses to mechanical engineers, computer scientists, software engineers, etc. And so today I'm going to talk about robotics for the streets, open source robotics for academics and the community. And this was a grant that was initially funded by the Open Source Hardware Association, as well as the Sloan Foundation. And during the pandemic, I had a reflection on who I was as an academic, as a professor, and it tied very closely to the work of Ernest Boyer and intersectionality that states that the work of a professor may be separated into 4 separate but also overlapping functions, including discovery, integration, application, and teaching. And he stated that there must be a more inclusive view of how scholarship informs these different things. So they're not really silos, but they're more like a Venn diagram with some intersections between your work. And so I use this in order to change the way that I teach robotics and the way that I think about robotics in terms of my robotics education and human-robot interaction research, and how it informs my teaching, how it informs my service, and how all of these things work together, where the knowledge is acquired through research, synthesis, practice, and teaching, where the scholarship of teaching, I educate and entice future scholars to transform, and extend knowledge. But then I apply that to consequential problems and service that shows up in the examples that I use when teaching it to my students. And because robotics is so inherently multidisciplinary, it also shows the connections between the disciplines, so the students are able to see how their specific major informs that area, And then it also leads to my coursework informing my students. Since I'm at a primarily undergraduate institution, I use my teaching and my courses in order to recruit undergraduate students who then do investigative research with me. And so this new vision for how I see myself as an educator is more of an educator for the world. So the first slide said robotics for the streets, my STEM is for the streets. So now it's not just about teaching the students who take my classes, but it's understanding that the work that I do is important and impactful beyond just the classroom by bringing robotics and STEM to people in the community at large. And by bringing people to robotics and STEM, I'm able to diversify the profession, because we all know that diversity in STEM is extremely important, because diverse teams, whether in thought, race, gender, socioeconomic background, ability, etc., will come up with the better solutions, and a more impactful team is one that has that perspective. I know there's other speakers today who are talking about artificial intelligence, but a really big one right now is seeing bias in AI and bias in those technologies, due in part to having teams that may not be very diverse and who are not able to see some of the impact of some of those protected classes and things that may happen because there's no one on the team who's diverse. So being able to do these things, I like to say, is me being a noir STEMinist, the word that I coined that represents the fact that me doing STEM work is to promote it to not just women, to Black and brown people, and using robotics in order to help diversify the profession. And so the way that we see that robotics is ideal for that is because robotics does have so many multidisciplinary connections. It's a mechanical machine that uses electronics like sensors in order to sense things about the world and then plan or act on the world by using the science. And then those interactions are going to interact with humans, like we said, which is why the human factor is equally as important. So seeing that, you can see that just the study of robotics has psychologists, it has sociologists, it has biomedical engineers, mechanical engineers, computer scientists, software engineers, etc. So I'm able to show people where they are represented in robotics. And that is that scholarship of integration that I talked about earlier. And that, when I do research with students, they don't stick in just one silo. They may have different majors, but they are also informed about the other majors, so that now a mechanical engineer may do programming, or an electrical engineer may do kinematics, or a computer science or software engineer may do some type of hardware work as well. So the robot platform that I have designed is called FlowerBots. It grows with the user, a play on also the word that, our school mascot is Rosie. So the robots are Lilybot, Daisybot, and Rosiebot. They're open source robots. Open source robotics, meaning that it is open source software and hardware. The design is freely available online, as well as all of the learning materials and resources are available on YouTube, social media, Hackster.io, Instructables, and GitHub. And it is a low-cost and open source platform in order to provide access to those that may be marginalized or minoritized in STEM, or those who are from under-resourced communities, with respect to not just resources and supplies, but maybe even a knowledge base of having people there who know about robotics and STEM and can teach other members of the community. It is 3D printed, so it is completely modular. Anything that's not 3D printed is a commercial off-the-shelf part that can be bought from any number of places. It's modular in that it can be programmed with multiple different controllers, including Raspberry Pi Pico W, Microbit, Circuit Express, Arduino Uno, Arduino Nano, Giga, etc. And a matter of adding more controllers is just a matter of making a module that is 3D printed and used to swap out the battery or power pack, as well as the mount for the controller. It's flexible enough to be appropriate for outreach, education, and research, which is why it's a resource not just for the community, but also for academics who may aspire to use robotics to illustrate either programming or controls or kinematics or design in their course, but may not be a roboticist. And it's appropriate for everyone from novice to expert levels, from kindergarten to collegiate level, university, graduate school, academics, professionals, and makers. And I will show you examples of different members of these communities who have used my robot. So these open source resources, like I mentioned earlier, are available, which makes it robotics for the streets because it takes it out of the classroom and it takes it to wherever you are. And some of the content, like I said, includes Instructables, Hackster.io, there's 3D printer files, there's CAD files. We've put things on Tinkercad that people have modified. So I'm now showing some examples of some of the content that you can find online for things such as making a robot that can do obstacle avoidance. I also had a user reach out to me that said, I don't have a 3D printer, but I want to take advantage of some of the resources that you are supplying. So I then took the box that I was using for obstacle avoidance in the first video, and here in the second video, what you can see is that I am using that box now to make the robot, because as long as you have access to the off-the-shelf parts, you can now make a robot that drives around. I'm not sure why that second video won't play, but trust me, that is the same box and that is the robot driving. So here we have high school students in Detroit who took my open source resources and built a robot for their class project. So here's a video from that.
The most challenging part was wiring the robot. The most interesting part was coding the robot and watching it perform.
And so the interesting thing about this, the interesting thing about this project is that that teacher saw one of my TikTok videos about the open source robots, reached out to me on TikTok, had her students then build the robots, and then sent me the TikTok video so that I can see. So that is a prime example of robotics for the streets, where I would have never met this teacher. I would have never been at a Detroit high school and been able to excite these kids about STEM. But by posting my things in all these different ways, she was able to find me. Here's an example of one of my robot evaluators. I did have the robots evaluated when I first designed them to come up with new designs. And the evaluators extended the work that I had done and actually showed how they were able to attach a camera to the robot. I had not done this at this time, and then wrote an app to drive the robot around. And this was graduate students at Louisiana State, and then show how they were able to get information about their engineering building by driving the robot and then projecting that onto their cell phone. So once again, the other benefit of having robotics for the streets is I now have a whole community of people who are able to take the work that I do and extend it to do something more than even I was able to do. So it's another way of informing my STEM, because I now have a greater community of adopters. So the other way that I do robotics for the streets, I also do robot hip hop slam poetry in order to teach young people about STEM and robotics. And it's a way to normalize them, seeing Black and brown people doing STEM and robotics that they may not see in the everyday basis. And it also teaches them about robotics concepts, and it inspires kids in order to learn more about STEM. And it's a great way for me to illustrate intersections between art and STEM. I also do this by writing romance novels, which is that top right, as well as children's books that show Black women in STEM experiencing success and trials, tribulations, etc., in their life as engineers and roboticists. So I'll show a little bit of this one, and then I think my time's coming to an end.
My newest robot. She has 4 wheels for driving around to see what must be seen. She also has a sonar, which is the most amazing thing. It figures out when things are close by sending out a ping. She listens to see when that comes back, to see what is around. How many of you knew that you could do that with sound? We write code for Rosie to help her to sense and plan and act. There's lots of things to do with robots, and that is just a fact.
Okay. Sorry. And so in conclusion, robotics is an ideal tool for showing connections between multiple disciplines, skill sets, and interests. It's also a great tool for recruiting diverse populations to science, technology, engineering, and math, as well as the arts. And there are many possibilities yet to be discovered if we let our imagination run wild. And one way to do that is to think of yourself as an academic and new ways of sharing your research and your profession with the world. And with that, I'm going to say once again, thank you for inviting me to speak today. And there's lots of ways to get in contact with me. You can screenshot that if you like. And with that, I am going to stop sharing and turn it back over to the facilitators. One second, I need to get to the stop share screen. I can get it to cooperate.
Thank you very much for your great presentation,
Thank
Carlota.
you.
We greatly appreciate your this presentation. And in the program, I just made the presentation of the whole presenters at the beginning. And we will have question and answers later on. If in the audience you have questions, you can post them in the chat window. And then at the end, we will have some few time to discuss all the presenters in like a panel at the end. So we'll give Diego the floor to present now.
Oh, do you say Diego? I thought I was the last one,
Ah,
but
no, no, not Diego, sorry.
okay.
Joanne is the second one, sorry.
Okay, going there. I'll share my screen. Voila. Okay, I hope you are seeing my full screen.
Yes,
Okay, so I can see the Zoom. Okay, I am sharing my full screen. You can hear me, you can see me. Okay, good evening or good afternoon, everyone. It's a pleasure to be together with all of you educators and sharing the education week of IEEE. Thanks for the invite. I'm going to quickly talk about the role of standardization when we designed remote laboratories for improving our delivery of engineering labs in the engineering education. Very quickly about the institution that I represent. I'm a professor at University of Antwerp and also at IMEC. IMEC is a distributed research center in Belgium. It's a flagship center in Belgium that covers research from chipsets, so basically from circuits up to digital solutions, cloud computing, and there we have gathered knowledge from electronics up to telecommunications. We have different teams doing this research. But on top of that, we have the educational mission to educate future engineers in different universities. So IMEC as a research center is distributed in Belgium, but the radio of action it's in the different technology hubs in the world. So we have units there that understand what industry needs, and we research solutions next to them. All that research becomes part of our educational content and part of our educational mission. I'm part of University of Antwerp, as I mentioned at the beginning. All these universities in Belgium are some research groups of IMEC are part of these universities. Mine, it's in Antwerp. We are the number 7 young university in the Times Higher Education ranking. But why do I use these slides? I like to start my talks with these slides, showing that research needs to become part of our educational mission. Our research needs to influence the content and the way we deliver content information to our students. And remote labs, that's what they do. we are researching in so many little pieces that make the whole remote lab. There's innovation in the different pieces regarding content, regarding telecommunications, regarding connecting the hardware to make it available. So all this combination delivers a remote lab. But what is a remote lab? So remote labs basically are we have virtual labs that are based on software solutions, and then we have the real labs, the physical labs that are based or run on top of hardware. How can we make remote labs? So remote labs, or actually I should call them online. In a generic way, we just call them online labs. So the online labs basically turn traditional labs based on hardware, based on equipment. In telecommunications, we call them test beds. Based on equipment, we turn them into, we make them accessible remotely using internet, using telecommunication systems to make all these physical labs available to students all over the world. Both virtual labs, which are based on software, and physical labs based on hardware, if they are accessible via telematic systems, telecommunication systems, they are remote labs. So a formal definition is that a remote lab uses telecommunications to remotely access physical facilities and to conduct research experiments. Summarizing, basically, we have remote students, remote learners that access via internet. They access remotely different testbeds, different hardware facilities to learn, to perform experiments and to learn the concepts and how they can be applicable in the real life and understanding the physical phenomena. There are different labs. There's a long history about of research labs. Many of the members of the IEEE Education Society, we have been working together through several years in different initiatives on remote labs. So starting by Go Lab, a European project, Forge Lab also in Europe. We had Go Lab that moved into enabling these labs for Africa, so Goes Africa. Certainly there's a big initiative in India called Virtual Labs. So there are labs and solutions already running in the world. There's research on the different bits and pieces that make a lab to become a remote lab. So, for instance, if we just Google, if we search in IEEE or ACM, the keywords like remote labs, remote laboratories, online labs, you can see that we have thousands of papers that are addressing X, Y, or Z aspects of remote labs, same as online labs. Those terms, if you look in the big data sets of research, we can see that there's a lot of solutions. So solutions that range from small devices, that a set of these small devices can be remotely accessed by remote learners in order to perform experiments, robots, wireless systems, cloud computing systems. As a matter of fact, this comes from one of the papers of my students, that we are managing remote access points and devices in the smart city of Antwerp. We are glued them together remotely via Amsterdam, and they are being managed in the cloud servers in USA. So this is how we can access remotely. But this is a lot of heterogeneity. And that's one of the downsides of having such a rich variety of solutions. The heterogeneity is the problem. So how can we solve that? With the standards. And this is basically what I want to share with you, what I want to promote among you educators, the use of standards for Okay, there's some microphone there. So the use of standards for engineering education, and in particular for remote labs that can help us to enhance the delivery of our experiments. So there are standards not only for accessing the hardware through software via telecommunications and making remote labs. There are standards in engineering education even to homogenize the content that we need to teach. So there's a joint curricula between IEEE and ACM that it's interesting for us educators to look at it. There's a bunch of series on these standards that they homogenize the content that needs to be taught. So the stakeholders in education have worked together to homogenize what are the basic knowledge, body knowledge that we should deliver to engineering students all over the world. So making sure that in India, in Bolivia, in USA, here in Belgium, we deliver the same body knowledge to the students, and we homogenize the content that we are teaching. So this is some type of standards regarding the content that we should deliver. So it's knowledge based. We homogenize what are the competencies that and skills that a student should gain with X, Y, or Z type of methods to deliver the education. So I want to share with you guys that standards are not only to homogenize how we connect things, but also how we make things, how we teach things in an homogeneous way. Regarding labs, remote labs, in IEEE Education Society, we have been pioneering on how to standardize the way we should build remote laboratories. So the IEEE standard 1876 released in 2019, an initiative basically done within this community and led by Hamadou. What focus was on how shall we do the following. The real objects, so the Internet of Things, basically, remote labs are based on devices. These devices can range from small IoT devices for communications to, as I mentioned before, to cloud computing, but those are educational resources. So how can we make sure that these educational resources are available in a standard way for any educator to connect them, to perform experimentation, and to obtain the data that gives the learning experience to the students. So this standard worked and released in 2019. Work took us like 3 or 4 years of hard work to have this standard. Basically looks from the smart device how we should connect and interface to the device, how the bits should be exchanged, the information. Also looks into a layer of what are the pedagogical aspects behind connecting to this device. What is the extension, the experience and the APIs that we should use in order to bring to take into account the pedagogical aspects. Moreover, there is a third layer, understanding what is the use cases, the scenarios and the activities that should be that the information should be exchanged. Therefore, a remote lab, it's not only connecting a device remotely and giving it to the students. It's understanding first the way we connect and interact as engineers, the way we teach as an educators, and what is the context that we in the context that we are using these tools. So this is yet another type of standard, and well, this is the type of information that we took into account when we make the measurements in the sensors in the IoT. But also there are more standards on what is the experience, what are the data analytics, that's the word I was looking for, the data analytics that we can obtain from an experiment, from a remote experiment. What can we learn from the interaction with the remote lab? How many times a student stops into some experiment? How many times the student makes some steps correctly or wrongly while experimenting? So we educators are capable to obtain statistics, data analytics to improve the way we are delivering this remote lab, and mainly to improve the experience. This it's called XAPI, so Experience API. This API captures the experience or the things that are the students are experiencing while experimenting in remote labs. So there are, as I want to deliver the message to you guys, there are standards about the content in engineering, about the way we connect the devices, about the way our students interact with these devices. How can we improve this, understanding the context, understanding the experience of the students? And there was still a factor that we were not taking into account. And in a new initiative in the future standard to be the P2834, yet another initiative in the IEEE Education Society in conjunction with a computer society as well. It's that we needed to understand how do we standardize the security aspects in this learning system. So how can we make these learning systems, which goes beyond than remote labs, how can we make them trustable? How can we guarantee that they are safe and trustable for the use of our students, to preserve the students' privacy and security and safety when they are using it. So we are now currently working, and you are all invited to join efforts with us in this standard. This is the link. But basically what we are looking for is what are the basics, the fundamental aspects that need to be secure when students interact with these systems? What are the aspects that the hardware, security hardware of these remote labs, or let's say trusted learning systems? The aspects on the security, the aspects on the usage of this and the experience of the users, and actually what are the policies that we should say the security policies that we should promote among our institutions and among the users of any of type of any users of this type of solutions. There are more standards that go beyond the hardware per se and the matters related to the remote hardware that we access in these remote labs. There are other initiatives that they are looking into as I mentioned at the very beginning, into the software-based, simulation-based systems. So this working group is looking into good practices for virtual classrooms. And taking all this into account, very quickly to wrap up, what we have done at the University of Antwerp, it's to put this into practice. All the slides that I have been showing to you, how do they get together? How can we truly use all these standards to deliver the right content with the right tools under the heterogeneous solutions that standard bring? For network management, in one of my lectures, what we have done is to first design the content. What shall we teach to make sure that our students gain the right skills when they take a network management module at my university? We have designed it following the CE joint curricula 2016, 2017, And we have made sure that every lecture follows standardized learning outcomes. Therefore, this can be used by any university in the world because the learning outcomes are standardized and they are easy um, to be adopted by any other university. So this is about the content as I started the talk. Then how do we make the remote lab? So we use the smart city of Antwerp. I'm the head of the connectivity there in my research line. But as an educator, I have used these resources that they are deployed in the streets of Antwerp, and we have used the layer of the 1876 standard in order to make the hardware accessible, in order to have this hardware with a layer of understanding the pedagogics behind the lab and actually understanding the environment. At the end, it's hardware that it's deployed in the middle of the streets in the city of Antwerp, the smart city of Antwerp. And what we do is to interface, so remotely, we drag and drop nodes. Basically, this node represents this node in the corner of Brainstrat in Antwerp. We connect several modes, and there's a whole session run by students at the other side of the world. This lab that follows these standards in content and actually on remote labs have been used in Ireland, in Brazil, in Cuba, in Australia, here in Belgium. So it's certainly the use of standards for engineering education, especially in remote labs, open up a whole world of opportunities for remote learners. And especially in my case, aiming to benefit those developing societies that cannot have the luxury to have a smart city just to teach engineering concepts. Bring this to them has been a really rich experience based on the solutions that in IEEE Education Society we have been developing and following the standards. So this is just an example of how we evaluate the success on the learning experience with our students. We have checked different aspects on the skills, the knowledge that they gain. We have also understood how to improve the methods and the delivery of these systems, all because we were capable to understand the data analytics behind the experience of these educators. To wrap up, so what did we learn and what do I want to share today? Remote labs bring equity in education. We can enable fancy engineering labs for engineering education that anyone in the world can access. And that's equity. And that's important for us as an educators. Another thing that we learn is that the students can have more time to access these labs because they are 24/7. So students can not only, they are not constrained to the 2-3 hours at university, but they can do it at home. That's a pretty good thing. Things that we have achieved. We have standardized curricula, the content, and also the technical approach on remote laboratories. What is still pending? Security aspects. We are addressing with the P2834 future standard, so working group right now. Security is something that we should look into it as developers of labs. As educators, we should pay attention on ethics and privacy aspects of our remote labs. And as standardization bodies, we should reinforce the link with industry and understand if the market embraces standards and if these standards are going to be embraced by industry. And the big question that we have, and in different forums, we are trying to understand is industry adopting this? Is industry willing to promote remote laboratories and to enable access to different assets via remote labs? Is there a business model? Is there an incentive to do this? That's the big question that Unfortunately, we are not able yet to answer, because there should be more engagement from industry with academia. And with this, I give the floor back, and thank you for sharing with me.
Thank you. Thank you very much, Joanne, for your interesting presentation.
I'm
Thank
trying
you
to
for
stop. Okay, yeah.
thank you for
Yes.
the presentation. We are going to move to the next presenter. And at the end, we'll have some questions and answers and discussion about the question you raised and the other aspects of the online laboratories, because online laboratories are generic, and we, in the standard that we developed, we have all the terminology that are used to when working on online laboratories. Thank you. So let's go for the next presenter. Can you hear me?
Yes, I think it's me.
Yes.
Am I right? Yeah, so I'm going to share my screen. Okay, can you see it?
Yes.
Okay, so first, thank you very much for inviting me to join this panel. I'm really honored to be here. And as you said at the beginning, Hamadou, I better known as Paloma. I have two family names, Maria and Paloma. But the Maria was something that was kind of imposed when I was young, and I never used it. So thanks again for this invitation. And I will start by introducing a bit myself. As you said, I'm full professor of my area of knowledge is computer science and artificial intelligence. And I'm at Universidad Carlos III de Madrid in Spain. I'm also the director of a research group called Interactive Systems, or DAYLAB, where I've been doing research in different topics, including interaction design, ubiquitous computing, visualization, social computing, citizen participation, and many other things. We also did applied research, and the main areas where I've been working are education, and that's why I'm here basically, but also culture, industry, health, and crisis management. Especially in crisis management, we use also a number of educational tools, especially for training. Another thing that I would like to highlight is I'm also leading a chair with the biggest telco company in Spain, which is Telefonica, that is about women and technology. And then I'm also quite engaged in many different initiatives and courses regarding responsible engineering, diversity, and applied microethics. And finally, I joined very recently this IEEE Education Society initiative as distinguished lecturers, which I'm very happy. And just to finish, I put some contact information in the right of this slide, so you can have my email and also my LinkedIn account if you want to get in touch with me. This presentation is about virtual, augmented, mixed reality, basically about affordable and useful experiences in education. And this is not the outcome of our specific project, but basically it's a quick summary of the expertise and experience we develop in a number of projects that we have been working at in the last 2 decades. Also, this is a very short summary of a lecture that I usually taught to different audiences because I teach in engineering, but I also teach to teachers because I was in innovative educational master, and also sometimes to cultural heritage students. So it's basically for all kinds of audiences. The first thing I wanted to say is that this is not about the metaverse, which is a very popular term that appeared 2-3 years ago and everybody was mad about it. This is about technologies that are quite mature, which are virtual, augmented, mixed reality, and how we can use them to really create useful learning experiences or teaching experiences. So first we need to disambiguate a bit these three terms. I use three examples. What is virtual reality? Well, virtual reality is basically when I move to a digital world and I leave the real one. So I don't see anymore my body or everything that is around me, and I get immersed into another reality, which is a virtual reality. The example I've chosen is an example we did in Second Life. Second Life was the predecessor of the metaverse. And we recreated the campus of the University of Salerno because we were collaborating with researchers there in Italy. And we did some experiments with the students who found the experience kind of very motivating and fun. But the truth is that Second Life wasn't very successful, and at the end it ended. Basically because in the end, in an educational environment, what we need is a pedagogical activity that nurtures our brain or challenge us or engage us in meaningful activities, not just representing avatars. In fact, there are many examples of virtual laboratories, for example, as Johan was saying before, or recreation of historical spaces or simulations that have been used for more than 2 or 3 decades to improve the acquisition of knowledge or skills, or also to be able to work more safely because dangers are virtual, or more efficiently because I can repeat the activities as many times as I need, or I can go at my own pace. I can do it almost everywhere because I do not depend on accessing a specific facility as I'm in the virtual world. And it's also more sustainable because if we are thinking about labs, we have to buy materials that we use, but in virtual labs, materials are endless and have no price. So virtual reality has a number of learning affordances that can be improved by using these systems. I can acquire better conceptual complex concepts, can represent 3D worlds or abstract ideas. I can also develop skills because I can do things in the virtual world. These kind of technologies are very motivating. So this is something that is important. I can learn while I have fun. And also the things I learn can be transferred to the real world. This is not a game. I can learn real things. Also, it's important that I learn in place, in a simulated place, but still it has some level of similarity with the real world. If the virtual world is complex enough, I probably can learn with other people, collaborating or competing. And there is some level of using the power of our body to learn, because after all, my body is represented with a virtual avatar. If we move to augmented reality, it's something completely different, because in this case, what we are doing is basically enhancing the real world with digital information that can be text, sound, or any other information. So the difference here is that I'm still in the real world, and I'm just increasing my perception of the world with information which is not obvious. The example I used here is a student who is using an augmented reality application to implement Arduino. So we did an experiment comparing students using augmented reality against students using the PDF manual, what they usually have. And what we found is that using the augmented reality app, what they do is they take the actuators or the sensors, they close it to the app, and they get information on the utility and also where they should be placed in the Bible. And what we found is that they not only were more efficient, but also the learning style was more exploratory. They not only did the task they were assigned, but they tried to learn more about the system. So what augmented reality does is to improve some learning affordances compared to virtual reality. First, it's more pervasive because you can use it everywhere. You can learn in the lab, but you can learn as you go through the streets. You can learn in the botanical garden, or you can learn everywhere. It's situated in real places, because in the case of virtual reality, the place is simulated. Here you are in the real place, which is also a limitation because you have to be there. Involvement is much more active because you still have access to the real world. You see your body, you see yourself, you see the people who is around. And since you see the people who is around, social interaction is much easier because you don't need sometimes to simulate it. It's just to interact as you do in the real world. Finally, when we talk about mixed reality, it's like a mix of real and physical and virtual. And in this example, you have a student who is using a mixed reality escape room. So you can see that he's wearing the head-mounted display, but he's using physical objects. In this case, what he's doing basically, he has a torch and he uses the torch to put light as he will do in the real world. So in this kind of hybrid systems, you get some more realistic embodied cognition compared to virtual reality, because you use your hands and you use real objects. So it's really much more useful. And the experiences are also more realistic, because in the virtual world where you touch something, you don't have haptic feedback, but if you are in mixed reality, you also touch things. And it's easier if you have to develop any kind of physical manipulation activity. These are basically the three things, the three technologies that you can use. But we have to be careful, because the goal is not creating something amazing, cool, using these technologies. But what we have to understand is that these are just educational tools. So their goal is to support a specific experience. And to do that, you have to try to move from the initial curiosity that is enabled or is sparkled by novel technology. And for this, I will use the theory of flow, which is very popular. It was developed by Csikszentmihalyi, especially for video games, but it can be used to any novel technology. And basically, the first step is that you use novel technologies as a hook, because they are really appealing and people want to use it. But curiosity doesn't last very much. So you need to move from this initial honeymoon effect to interest, to something that really engages people. And for that, what you have to do is to provide people opportunities to get involved with the system. These opportunities come from different kinds of stimuli, including intellectual stimuli, which are very important in learning, but also sensorial and emotional. And finally, if you want to get the full set, you need to move to engagement. And for that, you have to reach what is known as the flow condition, which is a psychological state in which you forget about time, which is basically what happens when you are playing video games. And to do that, what you need is to challenge people through a number of activities, so they get lost into your system. The other issue we see, which is important about this kind of technologies, is that sometimes they are seen as very sophisticated and to be used in the lab or in the university, but they will never be in a normal classroom. In a normal classroom, not only in the university, but also in high school, primary school, or any other place. And this is a problem that we can try to solve, trying to shift again the focus, not to very sophisticated software and hardware, but to try to understand which are the limitations and opportunities of quotidian experiences of what happens every day in real life. And for that, you have a couple of things that we have been working at. The first one is what is called affordable technologies, which are technologies that can be used by people because they are physically and cognitively usable, but also because they are economically affordable, because in many occasions, these kind of technologies are very expensive. And if you spend a lot of money, you have to be sure that there will be a real win-win situation. This is an example in which we compared a very sophisticated use of head-mounted display with using the phone in a cardboard. And well, it was a virtual lab about our engine, and they have different kinds of activities. And at the end, what we found out is that there was no difference in the learning gain using the more sophisticated interface or the less sophisticated interface. So sometimes we have to decide which kind of technology we have to use because it will be much more useful.
Hello, Paloma. Can you speed up a
Yes.
bit? Thank you.
Yeah, I'm finishing. Yes, I'm just finishing. And the other thing is try to enable people who is not technical in creating new experiences. And for that, you create end user development tools that make it possible to create augmented or virtual reality experiences. So just to end up, I have a couple of slides. The first one is that this can be very disrupting innovations, but we have to focus in the experience, as I said several times in the presentation. And we have to entice people to move from the wow moment to the aha moment, from this honeymoon effect that new technologies have, to discovering that this is what you have to use and what you want to use. And for that, you have to understand who is going to use it, for what purposes, when, where, and how, and especially why they are going to use this. So thank you very much for your attention. And again, thank you for inviting me to be here.
Thank you very much, Paloma. We greatly appreciate your presentation and hope to discuss more and get questions that we will answer very late. So next step. Let's Diego get the floor.
Okay, hi, can you hear me?
Yes.
Okay, great. Thank you. Thank you for inviting me to the to give this talk as part of the distinguished lecture panel. I'm going to be talking about technology enhanced assessment systems and opportunities and challenges. First, I'm going to talk about some background, some technologies. Later, I will talk about a new institute, AI Institute, the Invite Institute, and some final remarks. So, some information about me. My background is in AI in education, and I am a distinguished presidential appointee at ETS. I have done research in the areas of communicating assessment results to different audiences, and also technology enhanced assessments and learning environments. I'm a co-PI for a new institute, AI Institute in the US, and I'm board member and also associate editor for several journals. I started when I was in Colombia working at the university, at the FIT University, on a project called Conexiones. Later, I went to Saskatchewan where I completed my PhD, University of Saskatchewan with Jim Greer, Gord Makala, Julita Vasileva, and other professors there at the Laboratory for Advanced Research in Intelligent Educational System, areas. Now I work at ETS and I am part of Invite. Some words about learner modeling. What is learner modeling? So it is important for technologies to know more about the learner. Otherwise, technologies, or especially educational technologies, will treat everyone as if they were the same. So we can keep track of what people are doing, but there are some more information about learners that may be useful in some cases. In this graph, we can see how in the big blue figure here is the user, and there is a small figure, the white figure there, that is what we call the learner model, which is a representation of the learner that can be modeled by the system. And there is these four cycles, these four processes create a cycle where we capture information from the learner, we analyze it, we select what to present, and in this way we can start building a representation of the learner that we can use in systems. So it is important to manage uncertainty when we don't know what the student is doing. For example, it can use data from multiple sources. It can be used to support adaptivity, and we can model more than just knowledge. It could be metacognitive, affective, personal aspects, sociocultural aspects, and information about the context of learning, which is important, and we call that caring assessments, where we worry more about the learner from a whole point of view, the whole learner. And I will be talking about that a little bit later. So as time progresses, this representation gets better and better because we capture more information about the learner. And at some point, we are able to use it to make decisions or to inform the teacher about who is doing what or what supports are needed. And the teacher can use that information as a way to understand what's going on in these systems, in these educational systems. So some words about dialogue systems and what we call conversation-based assessments. So dialogue systems have been used in the past in different ways, and here you can see some examples, some early prototypes using AutoTutor by Art Grazer. And in here we also show some of the conversation-based assessments that we developed and tried at ETS. And they can be used to measure different constructs like English language learning, math, research, also science concepts. These conversation-based in assessments are important because they can help us gather additional evidence of what students are doing. And these are conversations with characters. So we can create or generate conversations when we want to get more information about the decisions that people make when using simulations or games. We can also offer multiple opportunities for people to elaborate. So we can ask a question, and if the student doesn't know, the character can ask for additional information, or the character can rephrase the question. So it creates a more interactive kind of assessment situation. In this example, we used conversation-based assessments in addition to other types of items or questions to assess science inquiry skills. At the beginning, the student interacts with a scientist, and they get to know each other. They talk about how to predict earthquakes. They learn about the background, about volcanoes, and we ask them questions about prior knowledge. Later, they get to place seismometers around a volcano. They get to analyze the data, and then they have conversations with these agents where they can talk about the data they collected and the prediction, and that way we can understand better why they make decisions, what kind of data they collected, and we can assess science inquiry skills. So, but in the past, we created these conversations using regular expressions and latent semantic analysis using the AutoTutor framework. It was based on ECD, evidence-centered design. So we were always thinking about the construct that we were going to measure, the evidence that was needed, but we have to generate scripts for all these. We created conversation diagrams, and it it was a process that took a while and it required many hours. Now we are doing something similar, but we are using large language models. We are using ChatGPT, but there are some other issues that we run into, because in the first case, it is more controlled. We know that conversations have 2 or 3 turns, but in using ChatGPT, it is more natural. The conversation can go in many directions, so we have to create prompts that keep people focused on the right constructs, and we gather the evidence that we need to gather. Also, for scoring is also more challenging. So some of the challenges that we can see when using different types of approaches to generating these conversations for assessment purposes are these trade-offs between natural conversations versus predefined conversations, where we have to evaluate things like semantic drift with large language models, where they start asking for other things, and when you go back and forth later, the questions are not about the construct but something else. So we have to deal with that. Also, scoring using large language models, since the conversation is more natural, sometimes people get to talk about many other things. So keeping people engaged and focused is more challenging. Also, issues about transparency, fairness, and bias. Do we know that these conversations are appropriate? Do we use human in the loop approaches to evaluate these conversations? And also the prompts can get complex. The issue of hallucinations is also an issue here. So we have to control that, and it depends on the constructs that we are measuring and the data that was used to train the model. So that comes to now, how can we make sure that those conversations are relevant and are appropriate? So we need to start thinking about the learner model, about aspects of the learner that we could use to be able to create conversations that are appropriate for the learner. So some ideas about open learner models. This is when humans have access to the information that is being modeled by the system. So questions like, what does the system believe about me? What kind of processes or what kind of data is used to support those claims or those beliefs? What data, how this data can be used to make inferences. And so creating dashboards and reporting systems using or interfaces that show aspects of the learner model is what we call open learner models. So we can create representations or interfaces that present the information in a way that can be easily interpreted. We can evaluate how people interact with this information, and we can support appropriate use of learner model information, and this can result in increasing trust and adoption of AI systems, because you get to see the data that the system models, and you can even make changes or add your feedback. So in terms of interpretability and explainability, when working with models, we have black box models or glass box models where they are more transparent, or you can see more about what's going on. And in this figure, you can see interpretability and explainability, looking at the complexity of the model and looking at two different users, like the machine learning engineer or data scientist, but also the final user. So we can make models that can provide some information for the person who knows about data to understand the model. But also we have to think about explanations that can be provided to the final user, to the teacher, to the learner, in terms of explainability to the end user, not just the person who creates the models. And there is a paper about that I can share with you. Now, all this information talks about, I've been talking about how important is to know about the learner, how important is to know about what people are doing in these environments, and knowing more about the learner is important if we want to support the learner as a whole. So we want the learner to look at aspects like how persistent, how engaged is the learner, things like that. So there is a new institute, a new AI institute that's supported by NSF and IES. We just started. We are on our first year, 5-year, $20 million, and we are a group of universities working on this project, on this institute. And the main goal of this is to be able to support learners as they learn STEM. So looking at issues like persistence, collaboration, resilience, creating data sets that we can use to create AI capabilities to support learners in these environments. So looking at the learner as a whole, looking at integrated learner models, using systems, and we have a big network of teachers and students are in the US through the STARS network. We are working on this right now. These are some of some of the people working on this in this project from different organizations in the US. It's a diverse group with people with different expertise, and many of these people are from ETS. So some final remarks. It is important to take into account that the learner is not just knowledge about, we want to know more about the learner, not just how much he knows or what he has done. Not all learners come with the same information, same background, prior information. They may have different situations going on. And that is really useful if we can create conversations that are appropriate and meaningful for learners so they can stay engaged in these environments. It is important to align the evidence that we collect with the constructs of what we are trying to measure or we're trying to teach in these environments. We talk about an evidence layer, which is a way of organizing all the data that we collect from multiple sources into in ways that we can trace back the data that we collect to how that data is used to support claims at the construct level. Also, it is important to create conversations based on different situations that are being modeled in the learner model. OLM approaches that are used to communicate learner modeling information, and important is to keep track or deal with data privacy, data security issues. So when people we know who owns what information, and the information is being used for purposes that are really useful and contribute to people learning, and that's it. Any questions, suggestions, please let me know. This is my contact information. Thank you.
Thank you very much, Diego, for your excellent presentation in this challenging assessment task for educators in this area, or large language models being used. The panelists are invited to answer to the question from the public, and also to ask question to each other. And so this session is only mainly to let the participant to know about these great speakers that are available to you, that you can request to IEEE Education Society to get them virtually presenting you what in depth what they are proposing, and also that can be virtual or in person. So on our website that I presented, the link that I provided you, you will be able to to find the speaker that fits your needs. So the floor is for all of you for questions and answers.
Quick question, could you please put the slide with the link back on? I wasn't able to get it.
Okay.
And I'm wondering if Diego could say more about the collaborative, the AI NSF collaborative.
Yeah, the Invite Institute, you mean? Yeah, this is an institute that is being supported by NSF and IES. And we are looking at how we can use AI to support STEM education for all students. And we are looking at issues that are more than just knowledge or learning particular concepts. So we want to create environments where we can model aspects like persistence, collaboration, and other aspects that may play a role in how people interact or learn STEM. The name invite means to keep people included, and so we want to keep people all connected, and we are working with many teachers and students and we are working on new projects that have to do with use of AI, foundational AI projects, learner modeling projects, new systems, new types of agents, things like that.
And is it for K to 16?
Yeah, K to 12, not 16.
Okay, so higher ed is not included?
There are some people doing, so the grad student, we have grad students, but mostly the studies are with elementary, middle, and high school students, but we are, yeah, it is mostly for K-12.
Okay, can you see the link for distinguished lecturer program?
Yes, thank you so much.
Okay, we're waiting for other questions. I have one question for Paloma. How what you presented is related also to what is what people are calling digital twins.
Well, it's related as well, the digital twin is simulation of whether a process, an industry, or even a human, but it doesn't need to be immersive. It can be a 2D representation. The difference is that the digital twin represents all the parameters in any process. It may be industrial process, a city, or as I said before, a human, because they are also used in health, but not necessarily using virtual reality. Probably it's a 2D representation.
Yeah, thank you very much. Like the 3D representation, but in terms of the real device or the real equipment or apparatus, or like human, all the data, the real data are like reproduced to the virtual, like not the virtual, but the 3D, the representation.
Yeah, the representation is not necessarily three-dimensional. The idea is that you represent all the parameters in a situation, and then you can probably analyze the evolution of different parameters. But
Okay.
maybe you have different visualizations, but not necessarily immersive, not necessarily using virtual or augmented or mixed reality.
Okay, thank you very much.
Thanks to you.
For Carlota, you talk about open robotics, open hardware, open software. And in your presentation, I think you had the link at the last slide. So I'm just letting the participant to know that they will get the presentation and connect to you about how you can provide useful information to work with within the framework of your project. You have something to add? I don't know. Are you hearing me?
I think that Carlota said in the chat that she had to go to another
She's
meeting.
not.
Maybe
Okay.
she left.
Okay,
Yeah.
Sheila. Okay, thank you. Okay, so keep on asking question and being dynamic in this session. So what I have to add also is everything you presented here is interesting also for us to share in our IEEE educational activities resources center, activity resource center, and also we presented yesterday some session about the standard development and also the virtual graduate study consortium. So you are invited to contribute to the IEEE initiative on virtual graduate study consortium and to the educational activities resource center. So if there is no more question, I would like to thank all of you taking part of this event.